to start a base on a single point localization, we're going to go ahead and screw our base onto our pole. We're going to then go ahead and turn the power button on when all our lights come on here. So it tells us the receiver's ready. We're looking at our power light here. We got full power, it's running off the battery. All right, so the power light indicator, we have green, yellow, and red. On our satellites, basically, this is going to count in series, so the green flashes are the US satellites, the orange flashes are the GLONASS satellites. All right, so that's going to go in series, and that's how many satellites we're tracking at the time. We want to make sure that we got a good number of satellites and that we don't have a quick red flash at the end of the GLONASS. That means it's still trying to get its location. Okay. Our Bluetooth light, when it's flashing, that means it's available to be connected to with Bluetooth. And our radio light, the amber light vertically, is our power board. That means we're getting power to the radio board. And then the two horizontal lights, the top light is for the base to tell that it's broadcasting in base mode. And the lower light is, when we're using our rover, that we're actually receiving the signal in rover mode. So with this all set up, we've done our checks, we've counted our satellites, we're tracking good satellites, and we can go ahead and get ready to start our base. The shortcut menu's down here. We're going to tap on Pocket 3D to open Pocket 3D. Okay, so when Pocket 3D opens, it's going to automatically open the last job and settings that we had. In this job we were using millimeters, so the first thing we need to do is change our equipment to regular GPS. So we're going to click on Setup Equipment, and we're going to use the Hyper-V RTK, and then hit OK. It'll ask us if we want to set that as our current equipment, so we say yes. And now we've got a new job that we need to start. So we click on Data, Project. Our existing project is this right now. We tap on that to get to our project list, and we're now going to start a new project. We're going to name this project Ligchine Single Point. Okay. We're not going to copy any information over from our previous job, so we make sure to leave that unchecked and hit OK. So now we want to make this our current job. So with that highlighted, we hit OK. And it'll ask us if we want to make it our current job, and we say yes. So the first thing we need to do is set up a control point that our base is sitting on. So we're going to click on Data, Control Points. Right now there's none in here, so we're going to click on Add, and our name is going to be base. Alright, our description is going to be post. And our coordinates, we're just going to call this 5,000, 5,000. And an elevation of 500. Okay. So we tap on OK. And we now have that point that we can start our base with. So we're going to go into Setup Base Station. Control point is going to be base. Bluetooth connection, we hit next. Topcon Hyper-V, antenna height is 0, measured to the base, click on next. Digital to radio, all of our radio settings are already set, so we hit next. Use co-op tracking, we never have on. Use multipath and GLONASS, we always have checked, so then we hit finish. Okay, so there's our serial number for the base. Highlight that, save for future use, and select. So it connects to the base, connecting to the GPS, waiting for satellites, and base started OK. So now what we need to do in our data, control, and control points, previously we put our base in, but it didn't have any GPS values. So if we highlight that and hit edit, now that we've got the 5,000, 5,500, when we click on the GPS tab, because we just started our base, we can actually use these locations for our single point localization. So we go ahead and highlight our use horizontal, use vertical, and hit OK, and then hit OK again. And now our single point localization is done, and we can go ahead and continue on with our topo. Alright, and we are now ready to connect to our rover. We click on Survey, Connect, select the serial number for our rover, hit Select.
RTK lost. RTK fixed. RTK lost. RTK fixed.
And once we get fixed, you can see we've got the green box that tells us we're in good information. If we click on that to see our residuals, it tells us we're initialized, the satellites that we're tracking, and what our horizontal and vertical residuals are. So at this point, we are now ready to shoot our transmitter location so that we have coordinate location and elevation on that point. So at this point, we're now ready to shoot our millimeter point. So we're going to go ahead and survey, measure point, control point. Anytime that we're going to have a transmitter set up on a point, it has to be a point that's in our control file. Alright, so that's why we're shooting this as a control point. We're going to name this millimeter GPS 1. To signify that it's our first point, and we're going to say this is a new description, an IR for an iron rod in this case. Click on OK. So we've got our coordinates. We're ready to go ahead and start our measurements, so we click on Start. And once again, we're going to have a 60-second shot on this. So once our measurements are achieved, it shows us the coordinate values. We click on OK, and you can see on the screen we now have a millimeter GPS 1 point. We can also view the data. We go to Data, Control, and Control Points. We've got our temporary base point that we want to now remove out of here. So we'll just highlight that and hit Delete, because we're no longer going to be using that point. So we have our permanent base point. We can actually expand that out and read that we have a permanent base and a millimeter GPS 1. If we want to view the coordinates, we can highlight it and hit Edit, and that will allow us to see the coordinate information. So we'll just hit Cancel, and now we're ready to go ahead and set our transmitter up over this point. So with our fixed height legs, we have the center piece that slides out, and normally we're going to run this at 1.5 meters. So at the 1.5 meter mark, we actually have a slide hole for the pin to slide into and lock into place. So we're going to lock that pin into place, run it up flush, and tighten the arm down. Go ahead and release all 3 legs from the holder and set our point right on top of the iron. At that point, we can go ahead and release the 3 legs. So with all three being loose, what I like to do is, looking at our level bubble, I hold two hands, one on each leg, flush against the mounts, and get the bubble center bubble. And at the point that it's center bubble, I'll go ahead and tighten one down. All right, if you're in the grass, obviously this is the point with them all loose that we want to go ahead and stomp on the feet to make sure they're nice and secure in the ground. Okay? Reason being, if we tighten it down and then stomp it, it'll lift one of the other feet off of the ground. So once we get centered bubbled, we're going to go ahead and tighten them down, making sure that they're tight, because once we put everything on here, we don't want it flopping around in the wind. But we also don't want to gorilla grip them and break the bead off. So once we have that on here, one thing that I like to check, take a torpedo level and set it at 90 degrees on here just to make sure we got a flat surface. That way, if your level bubble happens to be off, you know at least you got a good flat surface for the laser to work on. So the laser we're going to take out of the case, and we have the coupling that slides into place on the legs here. So we take the coupling out of the legs, screw it into the bottom of the laser, and let that slide down into place. And then we're going to go ahead and tighten the thumb screw down so that she's nice and secure. So for our setup, basically we have the location and coordinates of the MMGPS laser. We have our laser set up over the point, so we're going to go ahead and power it on. All right, when it powers on, we got a battery indicator light here that shows us the 3 stages of what the battery life is. All right, so what we need to do is set up our data collector now for the millimeter transmitter so that we can import the information from the laser. So to do our download of the laser, we're going to take our little stopper out here. The connector is key indicated with a red dot on top, and we're going to line the red dot up with the red dot on the laser itself and get her into place and slide her in. All right, and then plug that into the bottom of the data collector. So previously we were using regular GPS to find our locations, so we now need to disconnect from that by going to Survey Disconnect, and we need to set up a millimeter GPS equipment. So if we go into Setup and Equipment, and we already have one set up in here, Hyper-V millimeter GPS. So just to show you, we'll highlight that, click on Edit. So Hyper-V millimeter GPS, range pole. The sensor type instead of GPS receiver now is millimeter GPS receiver. Location still top of pole and the units are feet. Click on Next. We're still using a Topcon Hyper-V. Our antenna height is going to be 6.56 feet. Measure to the base with Bluetooth. Click Next. Our radio type is still Topcon Digital 2, serial port C, 38400 and RTCM 3.x. Click Next. Our laser zone receiver, on our unit itself with the Hyper-V, there's only one serial port, so we're always going to be in serial port A. Sensitivity will be on auto, and transmitters, in our case we only have one transmitter, so we're going to say it's on channel 1. On the advanced tabs, we're going to have millimeter aided checked, but we're not going to check calc weighted millimeter GPS. So then we click Next. It says our machine configuration is complete. So we click on Finish. use that as our current machine, so we hit OK. So now in our setup tab, we have millimeter GPS transmitter and receiver options. So we need to go into our transmitters, and you can see right now that the list is blank. So we need to add this transmitter to our list. So we'll click on add, and every laser has a serial number associated with it on top of the laser behind the handle. Alright, so R is X60575. So we're going to type in X60575 and then hit OK. So now we need to download the information from the laser to our collector. So we click download. It asks us to make sure that we have our cable connected, which we do. So we click on OK. And we now have a firmware version which has downloaded the calibration from the laser to our data collector. So we're going to set the channel on that. So channel 1 is what we're using. I'm going to highlight channel 1 and hit edit channel. So the channel is asking for the laser. What laser do we have on there? We only have one, so we're going to select that laser. What control point is it sitting on? So it's sitting on millimeter GPS 1. Our transmitter height has a measurement of 5.16, and that is to the PZL1 to the mark and the slant. So on the side of the laser we have a bullseye that shows the measurement that we're going to measure from the ground up to that mark. Okay, so with our tape we're going to measure from the iron up to the mark on the slant, and so you can see that we are at 5.16, 516. Alright, so with our measurements in here correct, we hit OK, and then showing us the information, the transmitter, control point it's set on, and we click on OK. So we've now got our information set up for our transmitter, and we now need to make our connection to our rover. So with our rover connection and the millimeter GPS, we have a PZS1, which is positioning zone sensor. Alright, so our sensor goes on top of the rod, but below our GPS antenna. Okay, so our GPS rover has a thumb screw that connects to the bottom of the rod. So we're just going to tighten that to that, and then go ahead and drop that down in the hole and tighten it up. And we have two ports down here. We have a power port and a serial port. The cable that goes from our PZS1 to our receiver is the same cable that has the indicator, and there's an indicator on top. So we line up the two red marks, slide it into place, and then we want to go ahead and basically make sure that we don't block our sensor. So I usually kind of wrap it around that way. Same thing, a red mark on top. Slide it in. Alright, so we're going to make sure that we power on our receiver. By holding the button down, we get a green power light. Okay, so we've got our rover on, we've got our receiver on, we're ready to make the connection with the data collector. So on the data collector now, we're going to click on survey and connect. Bluetooth number for our receiver, which is the higher one, 95. Hit select. It tells us that it connected to the head. It's setting up the millimeter GPS. All right, and now we're fixed, but it says we have no millimeter GPS because we're not facing the laser right now. The first thing we want to check is to make sure that we actually have communications with our laser. There's two ways you can look at that. Number one, on our receiver, the firmware button is flashing, and that tells us that we're getting information back and forth between the receiver and the rover. So our PZS sensor to our rover with the firmware button flashing there. The other area that we can check that is by clicking on Setup and Receiver, Millimeter GPS Receiver. And in this page, it'll show us our firmware version. So as long as that firmware version shows up, we have communication. If that's blank, then we've got a block in communication somewhere and we're not getting the information we need. So we can then click on OK. And once we actually turn this towards our laser, this should turn blue and tell us that we're actually tracking that laser. So now that we're pointed towards the laser, you can see that our GPS light bar is now blue, and it's got a number 1 telling us that it's tracking channel number 1. Now if we actually click on that, you can see it says initialized plus millimeter GPS. Alright, and the number of satellites we're tracking. And we click on the position tab, and we have all of our information as before. At this point, we're going to be ready to go ahead and do our topo of our job. Okay, so when we're calibrating the laser, it's going to tell us to turn certain faces to it. It knows which face by the information coming from the laser is facing you. So the face with the handle on it is always face 1, and it goes clockwise 2, 3, and 4. So those are your faces. So after we get done with face 1 and we get our shot on face 1, we're going to have to turn the second face to the laser. Okay? Now, we don't want to just turn 90 degrees negative, because if this is too tight, what will happen is we can actually unscrew that from the bolt, and we're actually raising it up as it's unscrewing from the bolt. So when we're turning our faces, we want to have our face 1 face in there. He tells us he's done and ready. So now we're actually going to turn this clockwise 270 degrees until we get face 2 facing for the calibration. Once we do that, it's going to, the self-calibrating mechanism in here is going to recalibrate itself. Once it gets recalibrated, then the unit is going to start to spin again. We want to wait after that unit starts spinning. We're going to give a signal to our guy that, okay, the laser's spinning now, but before we actually take that next shot, we want to give this enough time to settle down, usually about 30 seconds. So you can see this is in the process of calibrating, and now it's leveled itself and it started spinning. So at this point we can start counting to 30. Once we get to 30, we can go ahead and make our check on our second face. Once we get done with this face, then we're going to go ahead and turn it 270 degrees so that face 3 is now facing our calibration. So on and so forth. Once this gets done leveling and we get our shot, then we're going to go ahead, turn it 270 degrees so that face 4 is facing for our calibration. Our laser set up, we want to check the 4 faces to make sure that our X and Y axis are matching up and we've got good faces. So to do that, the first thing we're going to do is go into stakeout point. So we have a checkpoint that we're going to use. So we go into survey, stakeout, control point. We're going to select our checkpoint from the list and hit OK. So now that's going to give us our values, for our cut fill measurements. All right. So once we have a good face here, we're actually going to look at this, and write down our numbers that we have here. So right now for our phase 1, we've got a fill of 100th. All right. So now we're going to let Kevin know that we're ready to go ahead and turn the laser for our second phase. So we're going to give him the rotate motion, and he's going to turn the laser 270 degrees until we get phase 2. So as he's turning that, you can see we lost our millimeter because obviously the laser is no longer sending out that signal. So right now it's in the process of leveling out and doing its auto level and getting recalibrated. And then once it starts spinning, our light's going to turn blue, and we want to count to 30 seconds after it turns blue to make sure we've given it ample time to settle down. This is also a good indicator of what we have for difference between regular GPS and millimeter GPS. When we lose that laser, you can see that, you know, we're about 400 or 500 difference now, and cut, and now, you know, with the laser, we're in the ballpark of, you know, fill 100. So the difference right now between millimeter GPS and regular GPS is about a ½ an inch. So now that our light's blue, we're going to go ahead and count to 30. Once we get there, we can go ahead and average the number of shots that we have. Okay, so we've counted to 30, and we're averaging a fill of 200ths. All right. So now that we have that, we can tell Kevin to go ahead and turn the next phase. So what we're checking here is the actual axis itself. So phase 1 and phase 3 are on one axis, phase 2 and phase 4 are on the other axis. So we're checking to see the differences between the two faces on that axis to see if that ray is wobbling or if it's making a nice steady you know, plane coming out of the laser. So we've got our signal back, so we're going to count to 30. So we've counted to 30, and you can see we have a fill of 300ths. So phase 1 was fill of 100, phase 3 is fill of 300, so we've got a 200ths difference between on that axis, which is within tolerance. So we can go ahead and tell them to turn phase 4. And we have our signal back now, so we can start our count to 30. So now that we've counted to 30, phase 4 is fill 400ths. So phase 2 and phase 4 were both fill 400ths, so those are real tight with each other. And then phase 1 and phase 3 were within 200ths of each other. But our best three faces, you know, our 2, 3, and 4 were all at 2 or 3 or 400ths fill. So those are the faces that we would want to use to shoot our job site with. Okay, so now we're ready to topo our site, and we're going to shoot the existing flow or flag of the curb here that our paver is going to match up with. So to do that, we're going to do a polyline on the flag of the curb. So we're going to click on Survey, Measure Point, and Start P-Line. All right, that's going to ask us what layer we want to put this on. So we're going to add a new layer. All right, and we're going to call this the FG or FC for flag of curb. And then hit OK. We can also set our color that we want to use. So maybe for our color, when we tap on the color bar, we want to go with a green and click on OK. So that sets our layers, and then we click on OK, and now we're ready to take our shot. So we're going to go ahead and level up, make sure we're facing the transmitter with the sensor, and hit OK. And so that will start taking our shot and then tell us that it's got the shot. Okay, you can see that there is a box on here that indicates where the first point was. We can zoom in, and as we walk along, there's going to be a ghost line that follows us to say, you know, what the line would look like to our next point. So we're going to go ahead and shoot this about every 10-15 feet or so right now, just to show the dips that we have. So we'll go ahead and walk 10 foot over. So once we get to the point 10 foot over, you can see how the ghost line's forming, showing us where that point is at. Because we've already started the polyline, we can actually shoot the next point on the polyline by just hitting the enter key. But you could also click on survey, measure point, and next polyline point as well. So either way, obviously it's going to be quicker to just hit the enter key, but if you go that route, go ahead and take the shot, and you can see that there's actually a little arrow showing what direction the polyline is being drawn. So we've got this point, we can go ahead and go to our next point. Once again, we get to our next point, and this time we're just going to go ahead and hit our enter key. Okay, so now we've got that shot, and this is at the corner of our curve, and we're going to start working across the curve now. Make sure we're facing our laser, hit the enter key. Okay, now once we've got to our last point on the polyline, if this is where our curve ends, we can click on survey, measure point, and we have a option of either closing the line if we want to make a rectangle box, or we can end the polyline. In this case, we're just going to say it's an end polyline, and then you can see now it's drawn the green lines on there for our flag of curve lines all the way around. But we also need to pick up the low points in the middle or any spot shots that we need to define our surface. So we're going to go ahead and shoot the ridge line next. So in the same sequence as before, we're going to click on Survey, Measure Point, Start Polyline, but this is now going to be our flow line. So we're going to say we have a new layer of FL for flow line, and we're going to make the color blue. And we're ready to go ahead and take our shots so we get leveled up. Hit the enter key to take our next shot. And hit the enter key to take our last shot. And after we've completed our line, we're going to click on Survey, Measure Point, and End Polyline. So we've got our edge of curb all the way around, we've got our flow line in the middle, and if there's any spot shots that we want to take to fill in the gaps, we can go ahead and do that. So just to fill in the gaps here, you come over here, and there's two ways you can take a topo shot. You can click on Survey, Measure Point, and Topo Shot, and then this is actually going to ask you what point number do you want, what's the descriptor. So we're going to add a new descriptor and say it's an SP for a spot shot. What layer do we want it to go on? So we can put it on the default layer. What's our antenna height, and measure 2. So if all that's good, we go ahead and hit OK, and it's going to start to take the shot. Okay, so now we're going to go to our next point. And the second way that you can take a topo shot is by just hitting the enter key, and the screen's going to pop up and ask you the same information. It's automatically going to increase the point number by 1, so now it's shooting point number 2, a spot shot to the default layer. If everything is correct, you can either hit the enter key again or hit OK to take the shot. So when we hit that, it starts taking the shot and stores the point. So we'll pick up 2 more points on the other side of the line. So enter, take the shot and store it. And for the last point, enter, and there's our points. So now we have 2 poly lines, and we've got a couple spot shots in the middle, and we're going to build a surface off of these points. So in order to do that, all we have to do is, on the walking guy, we tap on that circle, and that'll bring up our bullseye. So we're going to use the bullseye to actually drag across our project so that all the points and lines are selected. When they're selected like this, we're going to click on Data, Calc Wizard, and inside our Calc Wizard, we're going to make a tin surface from points and lines. So we highlight that and hit Next. So that's going to show us what the tin triangles are going to look like based on what it's connecting. We hit Finish or Next. It asks us to name the tin. So we're going to name this is our final surface, so we'll call it Final and hit OK. And then it asks us if we want to set this as our current surface. We want to do this so that we can go ahead and make checks on the surface that we built to make sure everything works out good. So when we hit Finish, You can see now, because our surface options have the contours drawn on, you can see how the contours are flowing in this area. Alright, if we want to turn those off, we click on Data, Surface, and Options, and here's where we can actually turn the triangles, boundaries, and contours on or off. Okay, we can also set the interval that we want to see the contours at. So for right now, to make things a little easier to see, we'll go ahead and turn the boundary and the contours off. And so now you can see that all of our screen is on here, and it still has the selection point, so we want to clear that selection. So we click on Data and Clear Selection, and now that's taken that off the screen. So for us to do a stakeout to check our surface, and this is where we would actually, check to make sure that we're matching storm sewers, we're matching curb lines and locations. We're going to go into Survey, Stakeout, Surface Check. And when we go into Surface Check, we're going to get the icon here that tells us, what our vertical offset is for the surface, what the cut and fill is for the surface, and what your elevations are. Okay? We can change any of these settings to see what we want to see just by tapping on the screen. So if we hold down on the screen here and go to Show Text, in our options for Surface Check, these are what information is being shown on the screen. So if you want to reduce something and say maybe we don't want to see measure elevations, you would just click on that box and say none. Alright. Cut fill for the surface and vertical offset, maybe we don't want to see the vertical offset right now. So you would turn that to none. We're going to leave that on right now. One other thing that you can do is actually change the size of the text by clicking on the A. So you can see as I click on the A how it gets larger. And then the third thing we can do is actually change the color of the text by clicking on the three dots and selecting what color we want that text to be. So maybe we'll change that to blue. We'll leave that one at the default just to show you the difference. So now you can see we've got a huge vertical offset, and then our grade cut fill is in gray. Alright, and if we want to change that back to default, just go back to Show Text, and we'll go back to the black. And change our letter back to the default size. Okay. So now as we walk around on our surface, any place inside that surface that we go, we can actually check and see how our surface model actually modeled out. So as you can see, the two locations that we've been to so far are right on grade. Pretty close to grade there, just over a 1/4 inch. And this is what we want to do just to check and make sure that we've got a good model set up and ready before we load it into the machine. So this is our second, our check to make sure everything's good before concrete's coming and we get in trouble. So we've gone ahead and checked all this all around, and we're ready to send this job out to put into the machine. So all we need to do is click on Data and Project. Our current project is Ligchine State Plain. We click on that to bring up our list, and we now want to copy that. So we're going to copy from the internal memory that's stored in here to the hard disk. Okay, so we're going to put our USB slot or stick into the USB on the bottom. We go ahead and slide that in. And we now want to click on copy, and we're going to copy from the internal memory to the hard disk. So in the FC500, the USB stick is always going to show up as the hard disk. We then want to select the job that we want to copy. So we're going to come down here and find the Ligchine state plane, highlight that, and then hit OK. So then that then tells us we have one file copied, the Ligchine state plane, and we hit OK. And so now that's on our thumb drive, and we can actually take it to the GX60 and plug it into the machine to transfer it to the GX60. Just go ahead and remove it, and we'll go over to the GX60 now and load that file into the GX60. Okay, so to transfer our job to the GX60, we're going to take our thumb drive and plug it into the USB slot. And on our touch screen, we're going to click on the Topcon icon and go to File and Projects. So this is the project list of all the jobs that are in the GX60. And now we're going to copy from our USB stick to the GX60. So we want to hit copy, and we're going to go from the D drive. So whenever you plug the USB stick into the GX60, it's the D drive. So we're going from the D drive to the 3DMC folder. We highlight our Ligchine state plane and hit OK. And we have now brought that job into the GX60. To switch to that job, we click on the icon, go to File, Projects, highlight the state plane as our job, and click on OK. So that's going to load the project into the file. Okay. And just to make sure our surfaces are active, we go to File, Surface. We have a final surface in there, and it's showed to be shown. We hit OK. We go to File, Active Surface, and right now we have a check mark next to Final, so that's the active surface that's being used right now for the grades. And as we zoom in, we can see where our machine is located on the project.